So today I'll be discussing the many uses of Kubernetes cross-cluster migration of persistent data. I think we all know why Kubernetes is great, but I also want to talk about what are the use cases for multiple Kubernetes clusters. So if you think about it from an operational standpoint, you might have one single cluster. You want to overcome some scaling limitations. Maybe if you have a single cluster and that fails, you want to have redundancy. So that's another reason why you'll have multiple clusters. From a DevOps perspective as well, you might have an environment for prod, an environment for staging, an environment for dev. Or even today now, you might have Kubernetes running on your data center, and then you're being asked to leverage the cloud computing and resources out there too. So those are other cases of why you leverage multiple Kubernetes clusters. As I go on through this slide deck, we'll also talk about data management use cases, but also more importantly, the challenges around taking that data and moving it to another cluster, because there's no native tools within Kubernetes today to go and address that. So cross-cluster data management use cases. One great example is maybe you're running something on production today, and you're running a certain Kubernetes version, and they just released the latest and greatest version to go out, and you want to migrate and test that data as well to that new version. So in that case, you might want to migrate, move that data to that new cluster and test it as well. Or you might be from running Kubernetes in AWS today, and from a financial standpoint, it's better to move it over into Azure. How do you take that workload and migrate it over there? So these are just some of the examples of cross-data management use cases as well. But the challenge really is around Kubernetes is that these clusters are isolated. So if you look at here, you might have a production environment, you have a staging environment, and these clusters don't have any knowledge of each other whatsoever. And they're both isolated in terms of storage and networking. If we dig a little bit deeper down into the storage aspect of it, a lot of that important data sits on persistent volumes, PVs, right? And there's no native Kubernetes infrastructure to copy, clone, or migrate that persistent volume between clusters as well. And the other challenging thing is from a network perspective. So there's no network connectivity between the source and the target cluster other than the publicly exposed services. The persistent volume data is not typically exposed on the network for ingress or egress. So we really have to think about a way to transfer that data between those two clusters while making sure that we don't overload the network, and also understanding the storage bandwidth as well. Because if you're running in prod and you start moving all that data, it could cause some issues as well. And as you think about migrating and moving that data to a new cluster, do you really need to move the entire cluster, right? In those cases, you might want to, but you can also get pretty granular as well on what you want to move. Maybe it's just a specific namespace, maybe a specific label, and you could just take maybe the etcd and the persistent volume so that application remains intact into another cluster. Some other aspects to take into consideration as well on the storage side is not all clusters are equal, right? So you might be, in this example over here, I'm running AWS EKS on US West with a persistent volume running on storage class EBS, while if I want to move it to the other region and it's running a different storage class GP2. And in this specific scenario, on the left-hand side, it's using some CSI drivers, where on the right-hand side, it doesn't have CSI drivers enabled and it's using a different storage class as well. So some tools that are available today, open source tools, Valero and Rustic, can be used. You can install them both on the respective clusters, so the source and then the target is where you're going to want to restore it to. There's usually a common S3 storage endpoint that both clusters can access, because that's going to be your backup target, and then you're going to read from it to restore it into that target cluster. And obviously, you're going to have to create that target cluster manually as well, and then restore that data into it. Cloud Casa IO is another solution as well. So it's a software as a SaaS solution, which is installing lightweight agents onto your cluster, and then it gives you visibility into all of your clusters within AWS, EKS. It works outside of those realms as well too, but it handles a lot of the challenges that I discussed around networking and disk issues, because it has the ability to do throttling so you don't overload your production environment. And then there's other nice features and functions such as role-based access control, so certain users can have access to specific workloads for cloning and migration. And then also their deep integration with AWS and EKS, where they can go ahead and spin up clusters on the fly, so you don't have to actually create any standby clusters as well. So here's a high-level topology of the general workflow of how these migration tools will work. So if you start from left to right, you have your production on the left-hand side, maybe a QA on the right-hand side. Essentially, you install those migration tools or the agents on each of the respective clusters. It goes ahead, reads that data from the cluster, then goes ahead and takes a snapshot using CSI drivers of the persistent volume, and then moves that data over into number 3, that little thing in the middle, the object storage. And then when you go ahead and restore, it reads from that object storage and then writes it back into that cluster, as well as restoring that data into that persistent volume on the target end as well. I'm a firm believer of pictures are 1,000 words. So here's just a walkthrough of restoring a cluster, or namespace rather, within Cloud Casa. So go over here, you can click on Launch CloudFormation Stack, so it has deep integrations with AWS. After that point, it goes and detects it does an inventory of all your available clusters within the Kubernetes environment. And then all you have to do is simply it gives you a kubectl command that you can just copy, paste it into each of your respective clusters. And then at that point, it goes and detects all of the various namespaces that you have. You can select specific labels. And in this example, I'm saying, protect this test-website over here and snapshot it and then also move that data to my object storage as well. So from the restore standpoint, you have the ability to create a cluster on the fly for you, or you can choose an existing cluster. So in this case, I've chosen an existing cluster. It also handles certain things as well, like changing storage classes. So I'm going from one storage class to another storage class. You can input that information into there. So in this case, it was going from EBS to GP2. And then also I can add in specific settings like adding a prefix and a suffix as well. So when I go ahead and I run through this restore, you can go ahead and see on the bottom over there that namespace gets restored with the suffixes and the prefixes that I've appended onto there, as well as it's restoring onto that GB2 storage class. Right? So that's my presentation on this topic. I'm at KubeCon actually, so come by our booth as well. We'll be there if you want to check out our solution. Thank you so much.